Alright, so we're talking about solutions here, and one of the major concepts you need to understand about solutions is the concentration of solutions. Okay? To do the math with solutions, you have to be able to determine what the concentration is, and then once you find the concentration, you can do other kinds of math with it. And we did a definition. You were supposed to do homework where you defined the definition of concentration. Okay, there were like 4 or 5 terms I gave you that you were supposed to do definitions for. If you didn't finish in class, you were required to do it for homework. Okay? Now, there are lots of ways to determine concentration. Lots of ways to determine concentration. We are only going to be doing 3 of those concentration methods or units in this class. Okay? But all the concentration units, whether they're the ones we use in this class or anywhere else, they fall into 2 major categories. Okay. One of the categories has the amount of solute divided by the amount of solvent. And on that list of definitions you're supposed to have a definition for solvent and solute. So that's a major category. Now, when I say a major category, I mean that there are lots of ways of measuring an amount. You can measure the amount with volume, like milliliters or liters. You can measure the amount with grams. The actual SI unit of amount of a substance is moles, so you can use moles for the amount of solute. The amount of solvent could be in kilograms or liters. Lots of ways to measure the amount of solvent. Okay? The kind of concentration unit we'll be learning about a little later, not in this section of Unit 8, but later, that has this major category or this major kind of setup, is a concentration unit called molality. And the symbol that we use for molality is a smaller letter m, lowercase m. The other major category is you put the amount of solute on the top as you did before with this category, but instead of having the amount of solvent on the bottom, you have the amount of solution on the bottom. That's another category. Major category, and you can have lots and lots of different kinds of concentration units that fit in both of these. One of the concentration units that falls under this category, you did a little bit of math in class on yesterday, and it's called percent concentration. We'll be doing some math with percent concentration in this section a little bit later. Now, CONC is kind of a shorthand for the word concentration. If you ever see me write CONC, that means concentration. Okay? But what we're going to first start with that fits in this category is a concentration unit we call molarity. And the symbol for that concentration unit is a capital letter M with a line under it. Now, there's something you need to be aware of and keep in your mind when we're thinking about solutions, and that's about what a solution is. You need to know and remember and sort of keep in the front or back of your mind that a solution is made up of both the solute and the solvent. Okay, it's both. So when we're looking at these categories of solutions, or the concentration of solutions. What's in the denominator here is both solute and solvent, but what's in the denominator over here is only one of those, just the solvent. Okay? Now, the concentration unit we call molarity is made of two different measurement units that are compared in a fraction, this kind of fraction here. And the amount of solute for molarity we measure in moles. So we're going to have moles of solute. And the amount of solution in the molarity unit we measure in liters. Whenever we find a concentration in units of molarity, we often call that molar concentration. So you need to know, keep in the front of your mind and the back of your mind to solve problems with molarity. You need to recognize that molarity is in two parts, moles of solute divided by liters of solution. Okay? So here's a problem I'm going to solve for you, and then I'm going to let you solve a problem. Okay? If 4.75 moles of calcium chloride is dissolved in 44.12 liters of aqueous solution, what is the molar concentration? All right, so when you read a problem like this, you need to recognize I'm trying to find an answer in molar concentration. Molar concentration comes in moles per liter. So my answer, when I finish, needs to be in units of moles per liter, which I can then say is molar concentration. The way you set a problem up like this is you have to remember that you're starting with whatever the amount of solute is over whatever the amount of solution is, and then you convert. In this case, I'm giving you the starting amounts in the units you need. So later on we'll have to do some conversions, but this time I'm actually giving you the amount of solute in moles. That's what you need for the top. I'm giving you the amount of solution in liters, and that's what you need with the bottom. All you have to do is put this particular problem together in a fraction and do the math. So 4.75 moles of calcium chloride. Remember, MOL is just a shorthand for a mole. And we're putting it over 44.12 liters. Capital L is the symbol for liters of this calcium chloride solution. SOLN is a shorthand we use for the word solution. In chemistry it's used a lot. And then we do the math. I'm sorry, you need to go to the nurse? Well, I guess you guys can see the answer I gave you, that I gave you an answer. I hope you have your calculator out and you're doing this work yourself so that you can practice doing this. Now I have nothing I can cancel here, so I have moles of calcium chloride over liters of calcium chloride solution. I'm going to round this answer off. In multiplication and division, recall that you look at the number of digits in all the measured or calculated numbers in the problem. Both of these are measured. And the number with the least digits governs how many digits you want in your final answer. Leading zeros are not significant, so this is the first significant digit. We have 1, 2, 3 significant digits in our least precise measurement. We want three digits here and underline everything else. And round off 0, 0.108 moles per liter is molarity. And we said we can use the letter M with a line under it for that concentration unit. So I can write the answer in capital M with a line under it, calcium chloride solution. Can you? You just sit up. Zach, you just sit up. Yes. Solution is where we have a solute amount dissolved in a solution. The solute and solvent are together. And so by writing it this way, we're saying that this is the solute that's dissolved in an aqueous solution. But that brings me to the next point that I want to make, actually, that if we don't designate in the answer what the solvent is, it's assumed to be water. Water is used so much for solutions that if you don't say what the solvent is, you have to, what you're saying is, by leaving it out, that it is water. Okay, so this is something you need to remember and use. If the solvent is not named, then the author which can be you. If you're writing it, you're the author. The author is saying,
Is that S-O-L-N?
S-O-L-N is the shorthand version for solution, just the shorthand for saying solution. Then the author is saying that water is the solvent. Okay? So if we're dissolving in anything other than water, you've got to say what that solvent is. If you fail to say what the solvent is, then you're saying to me or whoever's reading it that you're dissolving in water, and if you're not, then that's an incorrect answer. Alright, so here's a chance for you guys to practice. If 1.11 moles of phosphorus trichloride is dissolved in 15.4 liters of aqueous solution, what is the molar concentration?